Hi, we're the Exploding Gradients, or Group 13, and this is our group project, Mutant Fish Attribution and Classification. My name is John.
I'm Kevin.
I'm Layla.
I'm Raz.
So our background project is that we want to study the effect of mutations in DNA on the physiology and the development of humans. So in order to do that, what we do is to take zebrafish, inject them with mutations that we believe are related to autism. So each zebrafish will have 0, 1, or 2 mutations. And then we take images of these zebrafish and compare them to see if there's any differences in development or physiology.
Our client has asked us to use to build an image classifier using deep learning that's capable of distinguishing between these different zebrafish images, as well as using feature attribution algorithms to inspect what features were used for the classification. This feature attribution data will then go towards a user interface that allows researchers to interact with the findings, such as the raw images and the feature attributed images and the UMAP plot as well.
In this slide, you can see all the pipeline for our project. As you can see, we have the zebrafish images and the labels. The labels indicate which type of mutation the zebrafish has received. Then we feed the images and the labels to our classification model. We train a model, which is a machine learning model that's convolutional neural network based. And then after the training is done, we feed the model and the results, the predictions on the images to our feature attribution engine, which basically highlights the areas of the image that affects the classifier's decision on classifying the images as having 1 or 2 or 0 mutations. Then we feed the highlighted images, the feature attribution results to our user interface. We basically build a interactive website which has a UMAP built in, which shows these images on the website and highlights the areas of the fish which are affecting the classifier.
For our tech stack, we've decided to stick for the image classification part with PyTorch, specifically using the ResNet50 image classification model and Captum as our feature attribution backend. For the front end, we're using Bokeh.js and Netlify to help with deployment and being able to push this out onto the open web.
So going into our demo, we have a website that shows all of our findings. The first thing that the user can see is they can choose one out of the 5 feature attribution plots. So if they click on deconvolution, it'll open up a new page where it'll show deconvolution against the predicted labels. They can hover over a point and then it'll show them the associated image for that particular point. The next thing that a user can do is they can look through a feature attribution gallery where they can select a particular number of mutations, and then they can also filter by a feature attribution method. They can hover over any of these images, and if they click on it, they can get a closer look at a particular image. They can also do the same for confusion matrices. Here we have 4 of the feature attribution methods to hover over and get a closer look at. And then they can see who did what if they would like to contact us. And yeah, that's the project.